Hello world, today is the fifth problem of programming study skills, programming skills study set of LeetCode, and today's problem is repeated substring pattern. So let's get started. So what we have here, given a string s, check if it can be constructed by taking a substring of it and bending multiple copies of the substring together. What it means basically, we have a string and we have to return true if you can make s the string by taking some smaller non-empty parts, so a substring, and repeat it multiple times. So otherwise we return false if we cannot build, we don't have the same pattern in the string. So they're given some examples here, as if for example we have AB, we return true because AB we have AB is repeated 2 times. For example, as shown in this case, we cannot have the same pattern, so we return false. And for example, in this case, we have ABC repeated 4 times, or ABC repeated ABC repeated 2 times. So, and before we dive into solving the solution, what I always do is try imagine some. Oh, sorry. No, first, of course, we have to think about the retrieval, which means questions that might appear before solving the solution. And as I always do, first I check the constraints and ask myself what constraints tell me or can tell us. So the first constraint here is that S length is between 1 and 4, which means 10,000. So what it tells us, it tells that we can actually do something like n² solution, but in the worst case, and it sometimes still pass. But of course, it's safer in the interviews or in any other parts. Think of ON or at least n log n solutions, especially in Python. So, and here, the second one is S consists of lowercase English letters, which means it doesn't matter as much here as for counting problems, like we did before the last question, like valid anagram, because we're not counting letters, we are checking the repetition. So, but it does mean there are no tricky Unicode issues, so the string is simple here. Actually, this is why this problem is easy one. So, and the second question that appeared to me is, what possible substring lengths do we even need to test? All lengths or just only some parts? So should we check all string, or if, for example, some substring appeared once, we can return true? And actually, yeah. So here have this, but this is the question that appeared to me, and this is not. You can just read it or anything else. So probably it's not the main issue or case here. So, and I wanted to tell you that before I dive into solving LeetCode problems, first what I do is imagine a real world case scenario, so it would be more fascinating and more somehow I can remember it and inside my head. So probably the example here is detecting a repeating trading pattern in an event log. So as here, the problem itself is repeated substring pattern. So imagine you're analyzing a simplified trading bot log. For example, we have buy, sell, or hold. And for example, string like buy, sell, hold is what it means. It means that bot did buy, sell, hold, and then again, and it's a kind of a fixed cycle, which means we have some bug or an overly rich strategy or something is looping. Maybe we have some bug here. So this is exactly this problem. And it means like we can ask a question, is the whole log built by repeating one small block? So it means like we are doing always just buy, sell, and hold cycle, which means actually it's a problem So, and we will find it. If this is the case, so we can say that something is wrong in this. So in finance world, it's actually very important to check these cases. So this is actually the how we can build some imagine some probably real case in this repeated substring pattern problem. So let's now dive into the solutions. Probably the solutions that we have here. We have a straightforward solution, which is divisor. Then we have string concatenation, and of course, the last is Knut-Morris-Pratt algorithm. Why we need it, I will tell it a little bit later. So the first solution is straightforward divisor. So I'm not gonna stick into this. I think you can also think of this solution as the first. I just will go by the examples, what it does. So here we have, for example, is string s is made by repeating some smaller substring p. So of course we always can find some repeating patterns here, and it means that the length of this substring must be divisible to the length of actual string. So, and because we repeat p whole times, we have no leftovers, and we could do it at most using this operation, which is divisor. I forgot the name, float divisor, something like that. And so it means that this substring can be repeated at least twicely of this string itself. So what we do, we just take this substring, then rebuild. P should be repeated at least this times. And if it equals to s, we return true, otherwise we return false. Here we have the example. So for example, we have this string, and the length of the string is 8, and possible key values would be up to 4. So we check 1, 2, 4. And for example, in the first iteration, we check a and multiply it by the so n by when it check the divisor by n times, which is 8. So we multiply it, and it's not the case. So we go to the next iteration, and then, for example, check a, b, and when we multiply it by divisor by times, it means that it will give us this string, and it equals to s, and we return true. Probably this is the solution. Yeah, this is the solution for the first straightforward approach. And the complexity of this would be n squared, probably n as up to n divided by 2 in on for the work itself. So it would be n squared, and probably the space complexity would be on. So yeah, this solution can pass, but we have to deal with something more efficient. And here comes string concatenation, or what it actually is. So, for example, if string s is made by repeating some smaller block, then when we double it, for example, when we do s plus s, which means when we do ab plus ab, here we would have like we do it twicely, and then it will appear. So it means that the original string s will appear inside that doubled string. So not only at the start, but not only in the end, but also somewhere in the middle. So, and we check if this is the case. And for example, if s found inside this doubled string, it means if yes, so s is repeating. If no, it's not repeating. And why do we cut the first? So why we cut, for example, when it's doubled? Why we have to cut edge? Because so index 0, the obvious first copy, and index n is the obvious second copy. And that would make the check actually useless. And we remove the first and the last character to prevent this trivial match. So probably here's the example. If we have AB, and it's n is equal to 4, and we double it, and then we cut the edge and check if AB is inside this. And yes, AB starts in index 1 of this string, and we return true. Here's the otherwise example you can see. And when it comes to the complexity, probably in the trick solution we build a new doubled string, and it has the length of 2n minus 2. And so far building this would make on the complexity of this. Then we slice the string by cutting the edge, so it's also on, and then we add extra space for t, also on. So, and the only mystery search here is s in t. So does t contain s? And what happens under the hood? This operation runs a substring search algorithm. So here's like in the naive search, we try every start position and compare characters. So worst case would be probably n square. But a smarter algorithm like two-way, KMP, Boyer-Moore will deal it with t plus s. So probably, actually, it depends on the language. If we will use naive-ish approach, the worst case would be n square, like for example in Python or in Java. But it depends on all the things, how it actually runs. But in C++, it would be the case, as it's inside the C++, it's already used the efficient approach of finding the needed string. So in C++, it would be probably on. But yeah, we have to say that the C++ standard doesn't strictly guarantee linear time. So it means that it's not 100% guaranteed, but probably it would deal in C++ in on. So what if we want to make sure that we want to on complexity in, for example, Python, we can use a Knuth-Morris spread algorithm to is more efficient way of finding the needed string. I dealt with this algorithm in my other problems, for example, in valid anagram problem. You can check my other videos, but today I just want to solve this problem in C++ using just a string concatenation problem. So what we check it. Here it works. Yeah, it works. So probably this is the solutions for this problem. And yeah, we solved one more problem in our series. See you tomorrow in the next problem of programming skill study set, and goodbye.